Okay, so example 5 is out of the context of the problem and like trying to figure out how to set up all of the equations. We're gonna do just the solving part, okay? So we are given an objective function, we're given the constraints, and we need to find the maximum value of that objective function. Okay, so we're skipping having to set those up, and we don't have the context of the problem. So we're just stripping it all down to make sure you understand the process. Okay, so first thing, we need to graph our system. Okay, so first we're going to graph. So x is greater than or equal to 0, y is greater than or equal to 0. So you've got those lines. Okay, this one we have our table, plug in 0 for x. You're gonna get 2y equals 5. So y is gonna equal 5 halves, or 2.5. And then if we plug in 0 for y, x equals 5. Okay, so I'm gonna do mine just to make it a little bit bigger of a region. I'm gonna go 1, 2, 3, 4, 5, 6. And then I also know I have to graph 2.5, so that makes that easier. Oops. Okay, so 1, 2, 3, 4, 5, 6. Okay, so 0, 5 halves, so that would be 2.5, so right here. And then 5, 0. And then that's solid line. And if we plug in 0, 0, 0 is less than or equal to 5, so you're going to be shading below. Okay. Then our next one, let's do blue. So this one, x, y, 0 in for x, you're going to get negative y equals 2. So that means that y is negative 2. Plug in 0 for y, so x is 2. So 0, negative 2, okay, so that's going off the graph, but that's okay. So let's see here. We have 2, 0, and let's see. It would be about here to give us our second point. So we're definitely going to need to solve the system to figure out where that point is for sure, because we did a little estimating. Now 0, 0, 0 minus 0, 0 is less than 2, so 0 is on that side of the line, so we're going to be shading above it. Okay, and then the x's have to be greater than or equal to 0, and y has to be greater than or equal to 0, so we're in this shaded region here. Okay. Because we have to be below the green line, above the blue line, and then inside. So x and y's have to be positive. Okay, so now second thing we want to do is our needing to find our quarter point. So this one over here is 0, 2.5. This one is 2, 0, and then we have 0, 0, and we need to solve our system to find that one. So those two lines, x minus y equals 2. I'm going to go ahead and multiply by negative 1. We'll just do on the bottom one. Okay, so you're going to have a negative x plus y equals negative 2. And then we'll just bring that other function down. And then we're going to add. Okay, so the x's cancel. I get 3y equals 3. So y is equal to 1. And then I plug that back in. X minus 1 equals 2. So x equals 3. So that corner point is 3, 1. Okay, so once I know my corner points, now I need to find the maximum value of my objective function. So that's my next thing I'm going to do. So my corner points I'm going to list here. And then my objective function is that. So we have 0, 2.5, 3, 1, 2, 0, and 0, 0. Okay, so plugging those in, 0, 2.5, you're going to get 0 here plus 2.5, so just 2.5. 2 times 3 plus 1, you have 6 plus 1, which is 7. And then 2, 0, you're going to get 2 times 2, which is 4, plus, plus 0, so that's 4, and then 0, 0 is going to give us 0. So our maximum is 3, 1. Okay, so it said to find the maximum value of the objective function. So our max value is 7 by using the x-coordinate 3, 1. So 3, 1 gives the max value of 7. Okay, so that's the process without all of the context of the word problem. The next one I would like for you to try. So what I would suggest is to pause the video and then try the steps, or start watching it and pause it to see if you can figure it out along the way. Okay, so our 6 steps are, the first one, we have to define our variables. Okay, let's see here. We're going to need, we'll end up having to do some more on the next page, but so first we're going to define our variables. Okay, so you're about to take a test that contains computational problems worth 6 points each and word problems worth 10 points each. You can do the computational problem in 2 minutes and a word problem in 4 minutes. You have 40 minutes to take the test and may answer no more than 12 problems. Assuming you answer all the problems attempted correctly, how many of each type of problem must you answer to maximize your score? So when it says the question, that's kind of where you're going to find your variable. So it says how many of each type of problem. Okay, so we'll let X represent the number of computation problems I do. And we'll let Y represent the number of word problems. Okay. So now my objective function, we want to maximize the score, so the number of points, okay? So we need to see where it talked about points. It said each computation problem was worth 6 points and word problems worth 10 points. So this is where I find my objective function. So 6x plus 10y. So z equals 6x plus 10y, because that's dealing with points. So that's going to give us the maximum number of points. Now I need to do my constraints. Obviously I'm going to have x has to be greater than or equal to 0 and y has to be greater than or equal to 0. I can't do negative number of problems, okay? Then I have to look at what kind of restrictions do I have, okay? So let's see, it said time was one of them. And it says you may answer no more than 12 problems. So the number of problems. Okay. So those are our two constraints. So the first one we'll do time. So it says that you have 40 minutes to take the test. So it needs to be less than or equal to 40. And we do a computation problem in 2 minutes and a word problem in 4 minutes. And then the second one, it says that we may answer no more than 12 problems. So X represents the number of computation problems, Y is the number of word problems. So my total has to be less than or equal to 12. Okay, so that's time and then problems. So now I want to graph that. And let's see here. We're going to graph the first one in purple. Okay, so plugging in 0 for X, Y is going to give you 10. And plugging in 0 for Y, X gives you 20. So 0, 10. So we're going to need 20 over there. So I am going to go by 2s. So this is going to be 4, 8, 12, 16, 20, 24. Same thing over here. 4, 8, 12, 16. So we have 0, 10. So 10 would be right here. And 20, 0. And we draw our line. And then our other one. 0 in for X. We're going to get Y is 12. 0 in for Y. X is 12. And draw that one. Okay, so we have a corner point right here. So let's see here. We also have X is greater than or equal to 0, so we're shading that direction, and Y is greater than or equal to 0. If you plug in 0, 0, you're going to be shading under that one and under the purple one. So this is our region. Okay, it's not always going to be that region. Like you can have lines where it ends up being like this other triangle region or something like that. So don't just assume that that's where it is. But if I plug in 0, 0, I'm going to be shading the direction of 0, 0 for this one. Okay, so we have our corner points, those blue ones. So we know the X and Y intercepts in 0, 0. And I'm going to need to go to the next page to solve this system. Okay, so we need to solve this system to see where they're intersecting, because I know that I didn't draw my graph super great. So 2x, and you're always going to have to verify this. So even if you are pretty sure on your graph, you need to verify. So we are going to multiply by a negative 2 to get rid of the x. So we have 2x plus 4y equals 40, and negative 2x minus 2y equals negative 24. So add, cancels our x's. We get 2y equals 16. So y is going to equal 8. And then we plug that back in, so x is equal to 4. And so you can plug it back into x plus y equals 12, so x plus 8 equals 12. So x equals 4. So one of our corner points is 4, 8. Then we want to maximize our function that objective function. Okay, so we had 0, 0. We have 4, 8, and then let's look back. We had this one at 0, 12, or no, let's see here. That's 0, 10. See, it gets confusing. 0, 10, and then 12, 0. And then we're looking for those values. So when I plug in 0, 0, you're going to get 0. 4, 8, 6 times 4 plus 10 times 8 equals 104. 0, 10, z equals 0 plus 10 times 10, so 100. That one was close. And then 6 times 12 plus 0 is going to give me 72. So my maximum was 104. So I need to answer 4 computation problems and 8 word problems. To get a maximum score of 104 points.